Welcome to this discussion on the 4% rule, including an Excel demonstration. The 4% rule is a retirement strategy, and the strategy is for people who are worried about running out of money, which is just about everybody. You know, that's one of the big fears for a retiree is that their money's not going to last their lifetime. And so the 4% rule, it's quite popular. You could Google it. There's a lot written about it. And I wanted to, give an overview of it and use Excel to explain the 4% rule, to demonstrate it. So here I have some data. It's historical returns and inflation that go back to 1926, and it goes through 2017. And so what we want to do is think about somebody retiring and think about the portfolio they might hold. They might decide to hold 75% bonds and 25% stock in their portfolio. And that's all I'll use here is just bonds or stock. Of course, it could be more complicated. You could throw in real estate investment trusts and gold and other securities and so on. But we're just going to use bonds and stock here. They're going to follow the 4% rule, so I'll put 4% here. And they have $2 million. And so we'll make that dollars. Make that 2 million. 2, 1, 2, 3, 1, 2, 3, 6 zeros. $2 million. And actually up here I want to make the percent stock work off of the percent bonds. And so if it's, for example, if I use 80% stock, it's 20% bonds. And so let's highlight the inputs here. This is what you're going to input. This is what you could change. Excel's still great because you could come back and make changes and it will recalculate everything. You don't have to do the formulas again. That's like the purpose of it. And so, or a major purpose. In any event, let's think of a retiree. So what do we have here? She has $2 million. Her distribution, her first distribution is going to be 4% of that. So see over here, I'm going to put 4%, that's in cell B5, times the $2 million in cell B6. That's $80,000. That's going to be her first distribution. And so her retirement years, let's say she's going to retire in 2020. And let's assume her life expectancy is 20 years, but we add 10 years because she could live longer than her expectancy. So if she's 65, we might expect her to live to 85, but we want to be sure there's enough money in there, in light of longevity risk, that she lives to 95. And of course, that's not perfect, right? She could live longer than that. And so we want to highlight those two, and I want to drag down to 2049. And I might want to make sure that's really 30 years. So I'm going to do equals count, open parentheses, left click, drag, close parentheses. Yes, it's 30 years. Okay, and now I need a portfolio return. Well, maybe I'll assume that her portfolio is good. We have to do the portfolio return. I have to calculate that. So the portfolio return, given 75% bonds and 25% stock, is as follows, at least for 1926. So take 75% times the historical bond return for 1926, plus this 25% times the historical stock return for 1926, and hit enter. Now I'm going to drag that down, and I don't want to lose the 75% and 25%, so I want to hold on those, so I'm going to put dollar signs around the column. Those are both in column B. Okay, and so now I want to calculate the historical returns for all the years. So I'm just going to simply take the mouse here. When you see that cross, double click. And that's the historical portfolio return. So look at here, 1927. A portfolio that included 75% bonds and 25% stock returned 12.76%, and so on. And so going forward, I might say, look, the future is going to be the average of the past. That might not be a good idea. We'll go on from there, but let's at least start there. So equals average let's take that portfolio return. I left clicked on the mouse. I'm dragging down the portfolio returns. And the average is about 7% or 6.95%. And let's do average inflation as well. Average versus inflation right here. And I'm going to come down here and see what inflation averaged during that period, 1926 to 2017. And then I'm going to assume that that's going to repeat itself. So equals this cell, and then drag down. So I'm going to assume every year, while this person's retired, all the way through 2049, she's retiring this year in 2020, that she's going to get the average portfolio return from the past. And I'm going to assume that inflation is going to run at the average. Every year it's going to be the average of what it was during the period 1926 to 2017. And the beginning balance on January 1st is $2 million. She'll take out $80,000 the first at the very beginning of the year, because it's just like an annuity due pattern, right? Because she's retiring, she needs to take out her money early in the year because she's not going to have any paycheck. So she'd put that in the bank and live off of it for the year, presumably. So we're going to do equals the beginning balance minus the distribution. So at the beginning of the year, she's already down to $1,920,000. However, the market is going to give her 6.9553% return on that 1.92 million. So what happens is she pulls 80,000 out, and the market puts back more than that. It puts back 133,541.22 cents. And so this column here is this plus that. That's the end of the year, and therefore it's the beginning of the next year's balance. So I'll double click. And now the next distribution, the way the 4% rule works, the way it's described, is the next distribution for the second year. It's the first distribution, I'll click on that, times 1 plus inflation last year. And there you go. So next year's distribution is $82,287.22. And we could double click that. And so you could see over time her salary, or so to speak, is actually distributions, is going to go up, just like Social Security. It's the same thing. The government looks at, in the case of Social Security, it's the government, they look at what inflation was last year and bump everybody up by that inflation rate the next year. Your Social Security payments will increase based on the previous year's inflation. And so what we see here is, the person here pulls out all these distributions. She starts with $2 million. So look at this. She ends with nearly $4.2 million. And so we think of that ending balance. That's when she's 95. And we can think of that a couple ways. Number one, if she's alive, she still has money to live on. We call that longevity risk. There's a risk she's still alive. Another thing we could think about is legacy planning. In other words, that money is available. Any year she dies here, here's the amount that's available for her heirs, including charities. And she might look at that and say, wow, when we're planning this out, let's do 5%. Let's pull out 5% the first year. In other words, it's $100,000. And see how that affects it. Maybe she say, you know what, maybe she still has a $1.5 million left. She might say, maybe I'll pull out 6% the first year. And then you start to run into trouble. In other words, the portfolio fails in 2046. And so the 4% rule is popular because we've tested this over and over again, and it rarely fails. It's like a decent amount that you could take out without risking failure. And so now what we've done here is we've used a point estimate for the portfolio return and inflation. And we learned in class that, the trends in the market really do matter. Think of if you have retirement money. If you have retirement money and it's at the very beginning of your retirement, you have a big pile of money, and the market has some bad years. At the same time, inflation runs high. So the market's declining while you're pulling even larger amounts out due to this high inflation. That would be a double whammy bad impact on your portfolio. So the market doesn't, give the same return, the average from a previous period. So when we test the 4% rule, we go further than what we've just done here, and we actually take returns from the past and use those to forecast what would happen to the portfolio in the future. And so let's do a run. We'll do a run. So I just click down here, and I have this set up, and we're going to be retired. Retirement years are 2020, 2021. We're going to go all the way to 2049. That's 30 years. We checked that out on the last slide. We'll put in 1926 up here, and that's going to be input data here. We'll do that. And make this 1926. Oops, I'm sorry. Reference this cell. Equals 1 plus that. So what I'm going to do is I'm going to assume during her retirement, which is these years, we're going to have the same portfolio returns and same inflation as the past. That's how we check and test in the academic research. That's how we check or test the 4% rule. And so let's see, if I put like 1927 here, all these numbers change. It moves 1 year forward. If I put 1942 there, whoops, let me put 1942, not 2942, 1942. You see that all the years, go from 1942, in this case, through 1971. So here we'd be assuming she's going to retire this year and stay retired for 30 years, but the same historical returns from this period are going to repeat themselves in the future. Well, let's go back to 1926, and let's use VLOOKUP. I want to grab the returns from the last slide or from the last worksheet. So equals VLOOKUP, open parentheses. This is the lookup value, right? 1926 is the lookup value, so I'm going to click on that. I'm going to put in a comma, and I'm going to go back here, and I'm going to highlight this entire table. And then I'm going to come up here, and I want to hold that steady, so I'm going to put a dollar sign before the C and after the C and before the G and after the G. And then I want to reference column 5 here because that's the historical portfolio return. Let's just take a look at that and make sure, right? I always like to check everything. So I'm going to go back here and say, okay, yeah, in 1926, that portfolio returned 6.94%. Look at the next year. It was 12.7625%. So let's double-click this and make sure. Yes, 12.76. So these are the historical portfolio returns. And then I want historical inflation. So I got to repeat that same thing. VLOOKUP. I'm going to reference this year right here, 1926. I'm going to go copy that table, so I'm going to hit the cover sheet. I'm going to copy this table right here. And I want Excel to hold steady on the table when I drag down to the next cell, so I'm going to put a dollar sign here, a dollar sign here, a dollar sign here, and a dollar sign there. And then I'm going to put in a comma, and I'm going to reference the fourth column because that's where inflation is. So I'll show you in a minute. We'll go back to the cover sheet, and indeed, inflation's in column 4. So I had my column headings up here so I knew where to reference. And then I'm going to double click. Let's just test this. 1933, the market return was 14.87%, and inflation was 0.51%. So let's just look at 1943. I always like to check everything. Here's the portfolio return, 8.58%. Oh, that's 1943. Sorry about that. So I look here at 14.87% and 0.51%. And indeed, that's correct. And so let's try this. We'll put in the January 1 balance equals, let's go back to the cover sheet and just click on 2 million and press enter. The first distribution is 4%. So I'm going to go back to the cover sheet and take this percentage, and I'm going to multiply it by this amount right here. Here's your $80,000. Next year, the distribution is going to be the distribution this year times 1 plus last year. See this up here? It's not this year's inflation, but last year's inflation. That's how the rule works. We take last year's distribution and multiply it by 1 plus last year's inflation. And it's actually deflation because it's negative this year. It was like negative 1.49%. And so we see the distribution in the second year would be about 78,808. We could drag this down. Those are the distributions. So they're going to take out these distributions over the period of their retirement. And we're planning on them having enough money to last 30 years, even though the life expectancy is only 20, because they might live longer. People do live longer than their life expectancy. Life expectancy is just an average. So equals this minus that equals this times the portfolio return, wherever that is, equals that balance plus the growth equals right there. Okay, and then we'll double click and we'll highlight all that and come over here, double click, they'll all go down. You see, okay, this first run, which is 1926 to 1955, if those portfolio returns, the stock and bond returns, if that repeats itself, given what did we have here? 75% bonds, 25% stock. If those same portfolio returns happen going forward, and inflation is the same as it was during this period. So we're using historical inflation and historical portfolio returns, and we're saying if they repeat themselves during your retirement, that's how much you'll have at the end. And now I could do another year. Let's take 1927. Watch this. It's going to go from here to 1927 to 1956. It's like an overlapping sample, we call it. And you have that much money left at retirement. And so somebody might look at this and go back, and say, what, I'm going to see what happens if I take 5%, a 5% distribution. And they'll have a little less left. And they might say, well, let's look at 1945 to 1974. If those returns and inflation, if that repeats itself, well, actually they ran out of money. So 5% didn't work for this period of time. I maybe change this back to 4% and assume they're only going to take 4% the first year. And then that does work. And so you can see how this works. We take previous data and we say, well, what if that happens again during your retirement? What if the returns during your retirement are the same as they were during this period? Right? And then we might go let's say 1973 to 2002. What if the market's behavior, the portfolio returns and inflation runs at those levels over the period that you're retired, which is right here. So if that repeats itself, you'll have this much left at retirement, and so on. And so you might check this like you check your portfolio. You'd actually get 62 runs out of it, and maybe one time out of 62, the portfolio would fail. In other words, there'd be a negative number here. And if that's the case, you'd say, well, the failure rate is 1 out of 62. Or a better way to say that is that portfolio survived 61 out of 62 times. And so that's the 4% rule. Again, the 4% rule says the first year you're going to take a distribution equal to 4% of your retirement balance at retirement. And in subsequent years, you're going to increase that distribution according to last year's inflation. And another thing that we found from studying this in many different studies is the best asset allocation is actually like 30% bonds, 65% stock. Like, look in this case, how let's take 1926 again. Look how much money is left in the account. And but you would tinker around with this and for your client, and you would find, based on the past, what's the best. And of course, you have to tell them the past doesn't always repeat itself. That doesn't happen all the time, and therefore there's no guarantee. You just say, based on the past, your portfolio, past data, your portfolio has a 1 chance out of, let's say, 62 chance of failure, if that's in fact what you got when you did your analysis. Thank you.